Hi, Assalamualaikum. My name is Siti Aisyah binti Badi Hisham. So here I will present my final year project, which is development of a lightweight, high strength or flexible structure for underwater sensor holder using selective laser sintering SLS. My supervisor is Mr. T.S. Muhammad Zakaria, who guided me throughout this project until it finished. So for the introduction in this project is Sungai Melaka is well known as the signatures of Melaka with their river cruise boat. So this project will be working together with Perbadanan Pembangunan Sungai dan Pantai PPSPM to measure the water level of Sungai Melaka by designing the flexible structure for sensor holder with height, strength and lightweight. It's important to produce accurate reading of Sungai Melaka water level. The flexible structure for sensor holder is a clip in front of mini boat. The problem occur when the sensor probably will pull out from water surface if not flexible due to width. The finalized design has to go through the finite element analysis FEA to choose the best design with high strengthness and producing the structure holder in 3D printing selective laser centering LSS with material polymer nylon P12 where the material has good mechanical properties. And then the objective of this project is to design a flexible structure for underwater sensor holder. That's the first one. And the second one is analysis the structure using finite element analysis FEA in CATIA software. And the last one is to fabricate the final design using 3D selective laser centering SLS technique. And then the scope of this project is to design a flexible structure for underwater sensor holder, analysis the design flexible structure using finite element analysis FEA using CATIA software. This will use a 1 meter stress to measure the factor of safety to this design. And the last one is produce the final design flexible structure using selective laser centering SLS technique. And the material used is polymer nylon P12. Okay, for chapter 2, which is literature review, method of measuring water level based on the past design. The first one is sonar, which is by using a pulse to measure the sea level until sea floor. The pulse will bounce back to the sea floor and then going back to the ship. And then the second one is the lead line, the oldest method to measure water level by old generation by using fathoms. And the last one, the tight gauge, modern water level monitoring station. And the material selection, which is a nylon P12 that I did some research, is widely used in medical and mechanical field due to its strengthness and far-touch resistance. Okay, we're going through to chapter 3, which is methodology. The first one starting with data collection, which is the research about past Sungai Melaka and past design for measure water level. And then literature review, find related journal about measure water level, the sensor, material selections, and SLS machine. And then design ideas by sketching 3 conceptual designs with different flexibility and structure. And then PDS, product design specifications, that the design going through to this analysis to choose the best one by using a PARC method. And then FEA, which is finite element analysis. After finish the design in CATIA, all these 3 designs will going through FEA analysis to detect which part is facing maximum stress and failure and to choose the best conceptual design. And number 6, the fabrication product, which is after finish all the design analysis, the finalized product will going through to SS machine to produce by using nylon material and fabricate to the mini boat. And the last one is product functional testing in Sungai Melaka. Okay, these are the 3 types of conceptual design that I have made to choose the best one. Every design have a different structure or method to hold the structure, and 3 of these were clicked by using G clamp to the mini boat. And as you can see, the conceptual design 1 and 2 is using a cage, whereas I can hold the sensor inside it, and while the concept design 3 is a flexible buoyancy where the sensor directly click to it. The purpose of the cage is that to hold the sensor so that it doesn't move to any axis and stay in the same positions and prevent from any rubbish or any particles stuck to the sensor while taking the measuring. So these are the 3 types of conceptual designs. Okay, for chapter 4, the results and discussion. starting with a product design specification PDS by using a part method. As you can see here, the conceptual design 2 has the highest score, which is 70 points, followed by conceptual design 1. If you still remember, the past design for these two conceptual design, they have a similarity, which is the structure and also the cage. But for this design too, it's a little bit more flexible due to the structure is getting stronger compared to the design one. And the method used to choose the best conceptual design for flexible underwater structure holder, and the rating was based on customer requirements they need in this structure design. This method was used to make a final design decision by presenting the parameter previously set the acceptable scores. And then moving to finite element analysis by using the von Mises stress from generative structural analysis by using CATIA software is a measurement that can be used to evaluate if material will yield or fracture. And it was commonly used on ductile materials like metals. And the von Mises creation state that material will yield if the von Mises stress under load or equal or greater than the yield limit of the same material under the same tensions. For this analysis, I've put the same load, which is 20 Newton in every designs. And as you can see, the conceptual design 2 has the lowest point factor, the lowest points of factor of safety compared to others, which is with the highest stress, maximum stress that it can bear. But even though this design is 5% of factor of safety, but it still need optimization and modification. So from here, we can say that conceptual design 2 is the best design in and have a good analysis, infinite element analysis VA compared to other design. Even the factor safety regulation is still need improvement to safely use in a real life. And then, okay, for the final design, concept design 2 has been selected based on past analysis, which is product design specification PDS and finite analysis element FEA. Then finally, this design concept has been finalized and has been chosen. And then I added in one part, which is the connector. Because I want to give more buoyancy and flexibility to the structure and sensor while taking the measurement, because it will move along with the wave whenever the structure hit the wave. And then the purpose of the connector is click to the mini board in front of the mini board while giving the structure more buoyancy and flexibility to move along with wave. And then the cage will tie in the seismic sensor inside it to prevent the sensor from moving to another axis or out from the surface. And this cage also can prevent any rubbish or any material stuck at the sensor while moving and taking the measurement. This is the dimensions of the mini boat, which is 50 centimeter long and 20 centimeter width and 9 cm high, and moving with 5.4 kilometer per hour and controlled using remote. And this is the bill of materials that I drawn in CATIA and label everything. That these are the materials that used in this project. There are 3 parts were printed in SAS machine, and there are 4 pieces of Allen bolt M8 and 1 screw and 9 M16 and a seismic sensor. And this also the assemble isometric view of this project in CATIA. And then after finish all the design and drawing in CATIA, all the 3 parts will is printed in 3D SAS printing machines that took 16 hours to complete the process. Then after completed the printing in this machine, it will proceed to cooling process and blasting process to clean the parts. And this machine is used in FTK lab. The name of machine is Fashion SS402P Selective Laser Centering SS machine. And the picture is the part after finish the SS process. Okay, these are the final product after assemble and fabricate to the boat. So as you can see, there is a kit, sesame sensor, structure sensor holder, the connector between the structure to the mini boat, and the brand for the mini boat is Type mini boat. And for the results, the water level measurement were taken at Sungai Melaka near Jabatan Panglima Awang. And the purpose of the measurement to test the functionality of the sensor when clicked to the mini boat, and the flexibility to its structure. The sensor have to take the measurement of water level accurately when sensor touch the water surface but not fully sink into the water. Then the sensor connected to the phone using Wi-Fi with the app named Fish Deeper apps that will show the reading and the graph flow or the picture flow of the riverbed until the river water level. And all the data were taken when the mini boat is moving while taking the data and click the sensor holder along with the seismic sensor inside the kit. And the pictures show the increasing of water level due to data was the graph show the increasing of water level due to data was taken starting with a sloping area at the end of the river, then continuing to the higher water level. And it showed that the data was taken accurately without sensors suddenly pull out or bounce out from the water or to sink inside the water, that prove the structure working well and give more buoyancy and flexibility to the sensor while taking the measurement. So these are the pictures or the condition inside the Fish Deeper apps when I was taking the measurement. As you can see, the picture shown in a Fish Deeper apps as the water level measurement starting from the water level surface to riverbed. The reading show the data was taken smoothly without sensors suddenly move out from the water surface, and also can show the datum of the river, and it proves that flexible structure holder made the sensors stay within the water surface constantly, and the data given are also accurate. So the second pictures is the example if the seismic sensor suddenly pull out from the water surface. So the pictures will show the unstable and inaccurate data. It will a little bit shaking at the pictures. So if that happen, by means the data is not accurate. But it's just example. I have to pull out the sensor to show the picture what will happen if the seismic sensor suddenly pull out from the water surface. So here is the real testing of the functional flexible structure for underwater at Sungai Melaka near to Jabatan Panglima Awang. So first, seismic center will be connected to Fish Deeper apps at phone using Wi-Fi. So as you can see, the seismic center at the apps will show all the things, especially the fish and the water level at the apps. Also, we can see the datum of the river. So here is the map at Sungai Melaka. So as a conclusion, in this project successfully to design and develop lightweight and high strengthness, which is the conceptual design tool, with 0.58 width and 7.7 10 power of 6 newtons meter square maximum stress, and a factor of safety strength of flexible underwater sensor holder. The structure managed to give the sensor to work within the water surface while taking the data. Polymer nylon PA12 from SLS machine also produce a lightweight with good mechanical properties and good yield strength. As the data shown, the measurements of water level at Sungai Melaka near Jabatan Panglima Awang shown the sensor took the data accurately. That's all for me. Thank you.